Hello and welcome to lesson 3 of scientific notation, where we're going to be comparing numbers in scientific notation. If you have a hard copy of lesson 3, you're going to want to start with that. If you don't, you will find it as an assignment on Schoology. If you have a highlighter, that would be a good thing to have, since the directions say to highlight things. And then you are also going to wish you had a pencil. All right, so when we compare numbers in scientific notation, one way that you can do it is you can take the numbers out of scientific notation, put them in standard form, and it's pretty easy to see bigger and smaller. So I'm going to go to number 1 on our examples, and I'm having trouble with the glare and the light. I actually already made this video once, and I'm going to come back and make it again, trying to get the glare better for you guys. So, in number 1, we're comparing these two numbers that are in scientific notation, but if we take them out of scientific notation, this number becomes 590 million, and this number becomes 6,800,000,000, and it's easy to see that this number is greater than this number. To do it using a couple of little cheaty steps, we can look at the original numbers in scientific notation, and we can look at their exponents, and whichever exponent is larger is going to be our larger number. So we can do the same thing with number 2. If we put these in standard form, this one would become 4,200, and this one would become 2,200. Well, obviously 4,000 is greater than 2,000, so this would be our larger number. But if we look at the exponents, this is a little cheat for you. If you look at the exponents, if they're the same, then look at the coefficients. Which one's bigger? This coefficient's bigger. This is the bigger number. I would like you to do numbers 3 and 4 and come back and check. Okay, number 3, this has the bigger exponent. This is the bigger number. Whoop, sorry. This has the bigger exponent. This is the bigger number. Number 4. This one's not in scientific notation, so to be able to compare it, we either need to put that in standard form or that in scientific notation. Once we do that, you can see that this has the bigger exponent, and it's your larger number. Okay, so a lot of times we'll have one similar to number 4, where you can't compare them if they're not either both in scientific notation or both in standard form. It doesn't matter which way you go. You can put them both in standard notation, you can put them both in scientific notation or standard form. It doesn't matter as long as they're the same. So if we were going to take this one, and let's say we took and put this in scientific notation, we see that they have the same exponent. So now we're going to look at the coefficients, and there's your larger number. Number 6. The first one is not in scientific notation. The second one is. We put this in scientific notation. We see that they have the same exponent, so we compare coefficients, and this is going to be your larger number. Number 7. How about you guys do 7, 8, 9, and 10, and come back and check for the answers. For number 7, we need to get this guy in scientific notation, or you could have put that one in standard form, either way. And then when you compare the ones that are in proper scientific notation, you can see that same exponent, so this one has to be bigger. And I already did that one. What am I doing? Here we go. This one. Compare these ones. that are in proper that one's not proper scientific notation, we gotta fix that guy. This would be, we made it two smaller, so that has to be two bigger. So now this one is going to be your greater number, even though it looked like that one should be because it was 14, but it wasn't its proper scientific notation, so that doesn't count. Once you get them both in proper scientific notation, then compare those exponents. Number 8. I hope that you guys can see all of this. I hope it's hard for me to keep checking up on the board to make sure that things are right. -5 is bigger than -6, so there's your answer. Number 9. Let's get them both in scientific notation, proper scientific notation, and then you can see -13 is greater than -14, so that's going to be the correct answer. And these guys are already both in scientific notation. The second one here has the larger exponent. All right, another thing that you are going to need to do is take a group of numbers and put them in order from least to greatest. So before you can do that, remember you can't compare them unless they're all in scientific notation. So looking at number 11, this is good, this is good, this is not, so we need to fix it. And this is not, so we need to fix it. Now that they're set, we can look for, we're going from least to greatest, so our smallest one is going to have the lowest exponent. That's the 4, is our lowest exponent, so this is going to be the lowest one. Then we have 5s, well there's 2 of them, because there's 2 of them we have to then look at the coefficient. This is the lower coefficient, so he's going to be second, he's going to be third, and our highest exponent is going to be our highest number. Another way to do this is if you put them all out into standard form. So if I were to do that, I'm going to go on this second one and put them all out into standard form and see what happens. This is number 12. So this would be and this would be, and this would be, and this would be this. Okay, now it's really easy to look at those numbers in standard form and go ahead and put them in order. This one right here, obviously 3 is going to be our lowest. 59 is going to be our next lowest. This one I did wrong, sorry. This one's going to be our next lowest. 61,000 is going to be our next lowest, and 430,000 is going to be our highest. Sorry about that. I went too many spaces over when I put this one into standard form. So that shows you that you have to be careful putting them into standard form, because if you make any mistakes putting them into standard form, you're going to get the wrong numbers, you're going to get the wrong order. So it might be easier for you to just go ahead and look at those exponents and coefficients in scientific notation. You choose, do number 13, choose which ones you want, which method you want, do it, come back and check it. This one's good. I'll put that one in scientific notation. I'm going to put this one in scientific notation. I'm going to put this one in scientific notation. And the last one already is. So, comparing comparing exponents, this is my smallest one. The next one is the -4. The next one is the -3. These both have -1s. So I have to look at the coefficients. This coefficient is smaller. That means this is our biggest number. Okay? Raise this up a little bit so you can see the whole thing if you have any questions. Ooh, that looks a little out of focus to me. Let me see if I can make that any better. Hopefully you can see that okay. All right, and then the last ones that we have, we're comparing using greater than, less than, or equal to. These have the same exponent, so we're going to look at these coefficients. And this one's bigger. On this one, we're going to look at, ooh, look at those exponents. They're different. But are these both in scientific notation? Nope, neither one of them is. So let's fix them and put them in proper scientific notation. And we find out that those are actually the same number. Boy, I hope you can see that. I hope that's not a massive glare right there. And finally, these ones are negative, so this one's going to be just a little bit backwards. This one, they're both in scientific notation. So which one is greater? This one has a higher coefficient, so it's greater. But what it means is it's more negative. If it's more negative, it's smaller. All right. On the independent work, you're going to do all of this, follow the directions, ask me questions by Zoom or by email if you have any questions on what to do, and I'll see you later.